Well, welcome to this week's episode of AE Squared. As you know, here at Hiller Measurements, we're deep in the engineering world. And if you're an engineer, you know that your job is one of managing a lot of trade-offs. And today, we're going to have that discussion with somebody who spends their entire life either making trade-offs or putting their rear end on the line based on the trade-offs that other people have made on their behalf. And this is going to be a fantastic episode you're not going to want to miss. But first, I want to give you the latest on what's going on here at Hiller Measurements, so take a look. Meet Tom, married, 2 kids, and delivering the respect our country deserves to those who would threaten it. At Hiller Measurements, we design and deliver test capability to ensure Tom makes it home every time. If you represent the best in engineering talent, work with us. And if you build our nation's defense, we look forward to working for you. We are Hiller Measurements. And we're back. So today I've got the distinct honor to introduce you to Commander Rory Feely. And just in case you're curious, no, not that Rory Feely, not the professional soccer player in Ireland. But he is Irish, and there's a good story there for that. Commander Feely heads up the Naval Test Pilot School out of Pax River, but he's also part of a really intensely interesting startup that we're going to talk about today called HopFlyt. So I can't wait to introduce you, so let's get right to it. Commander, welcome to the AE Squared stage, even though it's remote.
Yes. Thank you. Thanks, Jeff. How are you?
I'm very good. I have been watching and chasing HopFlyt and your story now for the last couple months. And I have to admit, it took me the first month. I couldn't just get the wing shape out of my head. So I look forward to learning more about the wing and all that. But before we jump back on all that, it is interesting to me that a gentleman with a fine Irish accent is commanding a large part of the American naval force. Can you tell us a little story about how that happened?
Sure. And I will start out with, before I even get to my very, very, very small part in the U.S. military, I'm not the first Irishman in there.
Oh!
I would like to say that the 4th Commandant of the Marine Corps was an Irishman. And I think he was relieved for cause by SecNav at the time. So this is over 100 years ago. And then the first commissioned officer in the United States Navy was Commodore John Barry, who was also born in Wexford, Ireland.
No kidding.
So yeah, absolutely. And there have been plenty of other ones along the way.
So is it because Irishmen are known they like to fight? Is that the...
That may have something to do with it. And we're not known to sit still. I think from a population standpoint, the diaspora, 70 million people worldwide claim Irish heritage. Not a bad metric from a country of about 5 million total. So... Yeah.
All the cool kids are Irish.
Yeah, maybe. All countries are good.
Yeah.
How did I get here from Ireland is a question I get often.
Yeah.
My parents moved around a lot when I was a child. I moved here to the US. I was maybe 6 months to a year. And soon after, moved from there to Canada. My dad was a doctor, so he studied at the Cleveland Clinic, and then did a fellowship in sick kids in Toronto. And then 1979, I remember it because Jimmy Carter was president. We drove by the White House. We were flying back to Ireland. And so I lived in Ireland from 79 all the way until I graduated university in 93. Mm-hmm. And I was originally born there as well.
Right.
And then in that intervening time, my family had moved back to the States again. I always say they abandoned me because I was a senior in high school. So, most kids leave the home and go off to college.
Your parents left you.
And I just stayed in Ireland. And that's where my buddies were. And I went to University College, Cork.
Yeah.
And as soon as you graduate, you don't have a job. What does everybody do? They go home to get their laundry done.
Yep.
Yeah. So I came here to the States, and about a year later, I was in the Marine Corps. And that was 1994.
94. So this is I got a degree, and you walked into the recruiter and said, sign me up.
Yep, September '94 or September '94. I signed on the dotted line and went on active duty in February '95, and I was a private first class in the Marine Corps.
Wow.
And soon after, got a commission. Actually, went into as a PFC, went into the C-130 navigator role and was aircrew on C-130s for a couple of years, and then got picked up for a commission and became a pilot and started flying. And the rest is history.
You could be a navigator on a Herc as an enlisted person.
Yes,
I did not know that.
Yeah, it was a great job, fabulous profession. Really, really enjoyed it. I tell people that I've already had the experience of being replaced by technology, because back then they didn't have GPS integrated into the aircraft. And since, they had navigators to do all of the flight planning, fuel planning, and stuff like that.
Job turns into bringing lunch, sink snacks.
Yeah. And then suddenly GPS gets put in all the aircraft. I got to find a new job. And now the drones are showing up. I'm being put out of a job as a pilot. So.
Well, not quite yet. Not quite yet.
Yeah. Getting close to it. But that's ultimately in 5 minutes or less how I ended up here.
So then you went from Hercules to flying helicopters, yeah?
Yes, sir.
So
interestingly enough, I got pushed into Hercules,
right?
And I enjoyed getting pushed in, and I'll take a few minutes and relay that to you.
Yeah,
I'd started out enlisting in the Marine Corps doing what's called BHC, Basic Helicopter Course. Mm-hmm. So I was going to be a mechanic on helicopters. I really liked them because Magnum PI also aired in Ireland.
That's right.
And if you remember that little OH6 that TC used to fly, and it would come over a cliff in Hawaii and then dive down and fly out along the water. I thought that was fantastic. I said, hey, I'd like to do that. You know? And I didn't realize that I couldn't fly in them, but if I couldn't fly in them, I figured working on them would be a good start. That's what I did. I wasn't sure about this Marine Corps thing. If it didn't work out, I'd get out. At least I'd have a skill along the way. I've worked on helicopters, and things changed. As I was going through some of the initial training, I had done well on some of the aptitude tests that the Marine Corps gives you, and the student control officer said, "There's screening for navigator school next week," which apparently was a very difficult screening to get through. Mm-hmm. And I said, "No, Staff Sergeant, I'm going to be a helicopter crew chief." And he goes, "Shut up. I've been a helicopter crew chief for 9 years. Trust me, you want to do this." And that's a moment of blind faith, one Marine helping another Marine out. And I just said, okay, sure. And I did it and finished up. And that school has now since closed down. GPS has taken over more pervasively. So,
So you got in just in time.
Yeah, I guess, or right at the tail end. And it was fantastic. I really loved it. The C-130 is a great aircraft. It has a great mission for the Marine Corps, and I got to travel a lot as a younger man to places that one doesn't get to now. So I've been to Wake Island and a few other interesting places as all part of the job.
Yeah. So when you went into helicopters in the Marines, did you start with Blackhawks, with the old UH-1s? What did you fly?
So after basic flight training, I was selected for the AH-1W Cobra. This aircraft. This one right here. Yeah. This was a present upon leaving the squadron.
I have a feeling you have stories of the sandbox after 9/11.
I do. I was actually deployed during 9/11 and subsequently again in 2003 in Iraq, 2004, and parts of 2005 as well. And I remember.
Thank you for your service.
Absolutely. It's my pleasure. I love the Marine Corps.
I have the utmost respect for guys of your ilk, because I remember in university going through Air Force ROTC, and they always showed the videos from Vietnam of search and rescue pilots in the Air Force. And then when the video was over, then they talked about the average life expectancy of a helicopter pilot in Vietnam. And the only thought I had was, that ain't for me. But it seems that things have changed.
Things have changed. Our training is better. Our equipment is better. We focus on it more.
Right.
Like anything else, you figure out how to do something, and then people are naturally incremental improvers.
Right.
And the military is no different. And because we have to pay for, the treasure that you lose and the equipment that you lose. And it's not like we have a bottomless pit of either.
Yeah.
And then you wouldn't be able to maintain a volunteer force if you didn't care about your people.
Correct.
So those things are important across all the services.
You find yourself in an interesting way to pull those levers today, don't you? As in your current job, can you share with our viewers a little bit about what envelops your daytime these days?
Yeah. So right now I'm the commanding officer at Naval Test Pilot School, and our job is to create talent. I like to say make flight test professionals, although I think I get the best side of the job, because when I stand in front of a new class of aviators and engineers, I tell them I'm going to learn more from them than they are from me. But we take advanced aviators and engineers from the naval engineering community. We also train Army pilots, Marine pilots, and naval pilots, and in the ways of flight testing new aircraft. And the main reason behind that is the US government has a lot of combat systems in procurement, and those on the aviation side in particular, those systems need testing before they get deployed to the fleet. And that testing is a flight discipline, an engineering discipline, if you will.
Yes.
It mixes the skill set that they have from their aviation training to this point, along with all of the engineering that goes into understanding the aerodynamics, the electronics, and many other facets of flight test.
Right.
And we have to send somebody out the door that is a good integrator of the technical side of it as well as the tactical side of it. So the challenge that when talking about that is I can't get anybody I can't train anybody on what it's like to go to combat. That's just something you have to do. Nor can you train them about how to fly off the ship or how to fly in military flights and do that mission. You can't buy that. You can't teach it. It gets taught along the way, but it's an experience.
Right.
And so we have to take the military aviators and bring them in and give them the engineering skill set in order for them to participate in what are large engineering teams working on combat systems. So you name it, JSF, MQ-25, H-1Z, H-53K, UASs, Shadows, Triton, all of those. That our people go work on those aircraft, and they work on the flight test teams and often lead the flight test teams because they have significant leadership skills coming out of the military as well.
What is it that you imagine? You know, it's funny. As we have taken this show live over the last year, there is a certain consistency amongst a number of our guests. And that consistency is, I'm impressed with the quality of entrepreneurial ambition and execution that is coming from people who are in or recently having left being in active duty. You know, you and I are sitting here talking. We're about to talk about HopFlyt. And as you're talking, I could imagine you and Daniel Robinson from Red 6 getting along very good. You know, an F-22 pilot, flew Tornadoes in Europe, and now he's doing, training systems for the development. Colonel Greg Johnson, astronaut. Now he's on the speaking circuit. He's flying for other people doing test work. Hazard Lee, F-35 Air Force guy, has got his own podcast looking at how he can create a monetary stream there. What is it about today's fighting force that makes it such a fertile area to grow entrepreneurs?
Oh, that's a great question. I think in the military today, you've got a couple of characteristics that come out in the people. One, they've got a significant amount of tenacity.
Right.
Two, they realize that the problem, the challenge, the team is always bigger than themselves. So they're not just in it for them. Like, the thing that drives people in the military is their willingness to connect and help others alongside them, or, you can put it in the vein of suffer together or succeed together. And if you even go back and take a look at the word compete, it really means to strive together as opposed to be in opposition to each other.
Right.
So those are some of the I guess the underlying characteristics. And they like to be part of challenges that, like I said, are bigger than themselves. So there's a significant loyalty aspect to it. And then they get it, right? I mean, who wants to do the easy stuff all the time? So, it's where you don't see the light at the end of the tunnel, and how hard are you willing to push through that to make that light appear? Right? And I used to have a boss that says there's no such thing as luck. Good people create their own luck. Yeah, they don't get lucky by themselves. They create their own luck, and it's the hard work, and that's in there.
Right.
And along the way, the other thing that the military dispels quite frequently is that you need to have some sort of special skill. No,
Yes.
we take regular people, all types of backgrounds, all types of upbringing, and we put them in with other citizens and give them a job to do, and they get after it. And and that helps. Not only do they become good followers, but they also become good leaders, right? And they're willing to work with other people when everybody else would count it out. And it's the size of the team, because nothing we're going to do from here on out in the future that's going to change the course of humanity is going to be done by a single person.
No,
it ain't going to happen.
Right.
And the military is a very challenging and rewarding job. I mean, it's defending the nation, and there's a significant amount of sacrifice in there, and
yeah,
it's got some built-in filters along the way. Some people will do a couple of years. Some people will do a career. Some people decide it's not for them, and some people will really, really enjoy it and excel. And on the backside of that, you can always tell.
I wonder, what you do for a living is an intense crucible in managing risk and becoming comfortable with risk, mixed with discipline, but also, especially in the job that you have today, in terms of always having a disciplined approach to an open mind for creative problem solving, right? Going back to the old OODA loop type concept and its future developments, right? That honestly, it's basic, but that is the fertilizer from which innovation is born, into reality.
Yes. So, on the flight test side, understanding the risk on an aircraft that has never been flown before, anticipating what can go wrong, understanding when you're in actual flight test, if there was even a minor result that you weren't expecting, to stop and understand, is it an iceberg? Is 7/8 of the problem below, the symptom that you just, So that's anybody can build that into the profession. Yeah. Because it's professionalism. I used to know a test pilot. I still know a test pilot who'd say, hey, 3 small mistakes in an aircraft and I'm done for the day, regardless of how small they were. And it's tough to make that kind of call when you're spending lots of money, but obviously his rule for himself and how he conducted himself in the cockpit, he felt if he got to the 3rd mistake, there was too much outside of his purview. And it is, and you can see that across many aerospace industries, how one will minimize the risk. If you take something like a satellite and you want to put it into space, you have to have a very, very low risk tolerance, because once it's up there, you're not getting it back.
Yeah.
So that's what we do, though, from a risk perspective. We go through and we analyze it. We analyze what we think the hazards are. We go through safety checklists. We talk about it. We talk about it at a team level and get a consensus on, are we doing the right things? And then we also, along the way, to go with that risk, is we have to have a purpose. And is the flight test always matched up with the purpose? Like, are we setting out to achieve what we wanted to in planning? And I know that sounds a little strange, maybe. Well, why wouldn't you? These programs become very, very complicated, and like anything else, they could lead you down a rabbit hole if you're not careful and stay disciplined to stay on task.
So let's extend that further to your entrepreneurial endeavor with HopFlyt. Fascinating concept. Lots of companies chasing that same general space that is still, let's be straight, has yet to have been profitably monetized. That being a short distance air taxi or point-to-point communication. The pain point is real. You just got to be in rush hour traffic between DC and Baltimore to recognize that, right? But it's an interesting, as I look at your design and what you're going after, there's a variety of trade-offs when I look at where HopFlyt's going and other companies are going. So I'm curious if you can kind of give the introduction to HopFlyt and lead us on to how you and your team have arrived at the design that you're pursuing and why you think that it has a resonant need that may be better than others.
Yeah, the why behind HopFlyt is your time is precious to you. It's the
Mm-hmm.
one thing that we can't control when we come into the world and when we go out of the world,
Yeah.
right? That's the same for everybody. So very, democratic across the board, every single soul on the planet.
Right.
At the same time, our modern society has come with some drags on that, and you hit on it, the traffic being one.
Mm-hmm.
And if you go through and add up, how much just, let's say, the average American, because we have data on that, spends in traffic, it's 240 hours every year.
Yeah.
That is more time than you're going to spend on holidays.
Yeah.
Right. And you're not even thinking about that. So that's a significant drain, and that's quality of life drain. And if you were to add that up over a career, you could spend 7 to 8 working years in your car.
Yeah.
And so now you're talking real numbers, and real numbers to everybody.
Right.
So that's the why do we want to get after this? Like, what are the fixes there?
Right.
How do we, and it creates other social problems too. So it creates, the supply and demand on real estate in a city
Mm-hmm.
is very high and makes it often
Yeah.
unreachable to the average person, just because access to the city is so much harder. So now if you can imagine that if you could work in a city and live wherever you want, and that the commuting time was small, would the
Yeah.
the prices be as high as they were?
Yeah.
And so those are some of the whys behind it. How do we get after the solution to that? When you take a look at what we've had for solutions along, man is always looking for better modes of transportation, whether it's horses, cars, rail, planes, boats,
Mm-hmm.
anything beyond walking. And some of the solutions along the way have come with some side effects.
Yep.
So exhaust pollution coming out of petrochemical vehicles or gasoline powered vehicles.
Right.
That creates issues. Not only does it create issues, and you may not be able to solve them all, but you may be able to, I'll say, spread load, because you can imagine the density of cars in a city changes the local environment in a city in terms of air pollution.
Mm-hmm.
Now, if we can use electric vehicles and our knowledge of flight, how would we build an aircraft that could fly people from point to point in a congested urban space?
Yeah.
And use the third dimension as opposed to being restricted to roads, and then also fly, as the crow flies, or straight line. Now suddenly your cities could take on a whole new dimension in terms of capacity, not necessarily be restricted by geography.
Mm-hmm.
So how do you build that aircraft?
Yeah.
Right. And they've got a name now that's growing up in the marketplace. They call them eVTOLs. The E is for electric, VTOL is for vertical takeoff and landing aircraft. So
right.
VTOL aircraft have been around for a while.
Yeah.
The Harrier is one.
V-22.
Depending on how. Yeah, V-22.
F-35B.
Yeah. And then some people would argue that depending on how you like to look at it, helicopters themselves are VTOL aircraft,
right.
And they are. So combining that knowledge of technologies with electric powers aircraft is where we are right now. And how do you design an aircraft that is capable of taking off and carrying passengers, taking off vertically, electrically powered, and carrying passengers and landing vertically in cities to overcome the traffic problem?
Yeah.
That's kind of like the big picture perspective. On the more tactical level, how do you build this thing, and will it work? All legitimate questions, right? Mm-hmm. Because it's not going to be easy, otherwise it would have been done already.
Yep.
And when I talk to people about this, I often use the story of the smartphone. Mm-hmm. And everybody has one now; they're in every pocket. But before the smartphone, we had digital cameras. We did have touch screens. We had, computer miniaturization.
Yeah. Franklin day
software.
Planners. Yeah.
GPS, and they just happened to be 6 or 7 different items. Yeah. And the key was integrating them into a single device. Yeah, and that now has grown to have uses all of its own that we didn't even anticipate at the time. Nobody anticipated when they were making the first smartphone of the level of connectivity of people thereafter. And this is just another way of doing that. How do we connect people? How do we move people? We're taking advanced knowledge of composite materials, electric motors, high performance flight computers, and other aviation advances, and trying to package those up in an aircraft that takes off and lands vertically like a helicopter and flies fast like an airplane.
Right.
Yeah.
So
does that make sense?
You have absolutely. You have some unique technologies that you guys are implementing. And this takes me to my love affair with your wing design, and that is it what your Venturi, as you call it, which the Venturi effect, it looks like a ducted fan with the top cut off, if you will. And I find it interesting that you talk about how it's creating lift. It's still a wing. It's not just a duct, if you will. But can you speak a little bit about how that design? My assumption is that without a design, you're gaining efficiency that equates to you don't have to have as much battery. It's increased range. It gets it off the ground better. What does that Venturi design give you that other approaches would lack?
Yeah, that's a great question and a little bit of a technical discussion. So I'll start at the very big picture. Almost anything we want to do is going to be, weight versus lift, range and speed, right? I mean, that's what it is. I mean, we need cargo capacity, range, and speed. And those are kind of like the fundamental principles for anything that transports anything else.
Right.
Now, when you break that down and you run that into some of the societal constraints that we have, I can't build a 10,000 foot runway in downtown New York. We have JFK, they have LaGuardia, and you can already see the traffic mess there. Right. So I can't give up that real estate. So how do we do the takeoff and land vertically, and then how do we make that happen on the engineering front? Let's talk about the plane side of things, like the airplane side of things. So having a straight wing and accelerating air over that wing generates lift. So how do we do that? You put some engines on it and you push it down the runway till you got enough airspeed, generates enough lift, and into the air the plane goes. And that is generally a very efficient way of flying.
Right.
All I have to do is make slightly bigger wings and I generate significantly more lift. When you come to hovering an aircraft, so if we'll put that to the side and we'll come back to it later because we're going to want to get to that efficient phase of flight. But when it comes to hovering an aircraft, that is more costly in terms of power.
Massively, yes.
Yeah, massively. So you have to be able to lift the weight off of the aircraft off the ground against gravity, and you have to be able to do that, for several minutes at a time.
Right.
And that energy expense is a lot more than it takes to just generate speed on a wing.
Right.
And then that still has to come from the power systems or the propulsion systems that are resident on the aircraft. So on the technical side, you accelerate the entire weight of the aircraft in air down through whatever propulsion system you have on board.
Right.
And you have to do that once every second. And that's just for the perfect case, the 1.0 hovering. In a practical sense, with losses and other things, you probably need to be north of 1.7 times thrust to weight ratio.
Right.
In order to hover an aircraft, have margins, and
hot,
have controllability.
Breezy day. Yeah, right.
Exactly. Yeah. And 1.7 may even be on the risky side.
Yeah.
So now when you look at doing that changes the dynamics of it. There are two ways you can do that. And I like to pick the extremes. It's all air motion and mass flow because that's what we're dealing with. So you're going to have, and I'll assume for the listeners here that we'll be talking about rotors, but it wouldn't necessarily have to be, but let's talk about rotors. So the entire weight of the aircraft is going to go down through the rotor system once every second. If that rotor system is small compared to the weight, which is called disk loading, or it's highly disk loaded, it's going to consume a lot of power because what you have to do is accelerate that air faster to maintain the mass flow necessary.
Right.
If that rotor disk is large, and this is what you see in helicopter designs, then you can accelerate that air more slowly and
less power.
You achieve the same mass flow, and the big difference there is power, and that power translates into fuel burn. So as we started to look at this problem, we said, how do we get some of that free lift that happens on the wing? And we weren't the first people to think of this. It's called the Custer Channel Wing, and it was invented by a farmer/inventor in Maryland, and flew first maybe in the late 40s, early 50s.
Really?
And it's and there were maybe 4 or 5 prototypes built throughout the decades, none of which ever took off. There were some other reasons that they didn't take off, but the science is sound.
Right.
Rather than pushing the aircraft down the runway to gain airspeed, why don't I just suck the air over the top of the wing
Right.
and create that differential in speed, which creates the low pressure on the top side of the wing.
Right.
And in his case, he just did it with a circular aerofoil, which works, and that creates lift. So you can go out and Google it, and you can see there are some
interesting
short takeoff and landing aircraft that were designed that had speeds shorter than or less than 25 miles an hour for takeoff and landing. And the problem is now, how do you maintain directional control at those low speeds when your other flight surfaces aren't effective?
Right.
Now come the more modern technologies. We can do distributed electrical propulsion. The drone industry and the small UAS industry has really given us that, as well as advances in computer stability and other flight control systems that can react faster than people, as well as better power matching between engines to overcome that. And you've seen these on other large projects, mainly in the military, like flying wings. Those are inherently unstable.
Right.
The computer does a lot of the stability behind the scenes. No human could ever keep up with that. And the same thing happens here now in these aircraft. There's a lot of computer stability and augmentation in there.
So does that to mean that with your approach, just thinking this out loud, you're still, I mean, from a full stop, and you're trying to establish a flying vehicle, you still are rotating these back with your thrust vector is primarily vertical at the start, or are you not quite? You're able to have it. You don't have
it slightly forward. So one of these technical things.
Yeah.
Well, maybe thrust is the right way. Gosh, my aerodynamics professors may be ashamed of me right now. The resultant lift vector is vertical.
Yes.
Right? So that resultant lift vector is going to come from a combination of the lift generated by the venturi, that channel shape in the wing, as well as the direct thrust coming off the propellers, and that is generally vertical on hover. So you'll actually see from our flight tests on our subscale vehicles, we have the wing tilted forward about 20 degrees, and about 20% of the lift is offboarded onto the wing.
So that means you can consume less power over the curve of transition from the initial vertical ascent to a horizontal vector of movement. You're more effective in that transition then as well.
Not only are we more effective in that transition, but we're also more efficient, but we're also safer. So one of the challenges that if you take a look back through aviation development and history is wing stall during those transition phases. So how previously aircraft designers would have removed this is they would have leading edge slats and aerodynamic devices to increase the lift capacity of the wing, and then retract them in forward flight to reduce the drag.
Right.
Here, when our motors are turning, they're always generating lift on that channel shape in the wing.
Right.
And so that helps minimize any anomalies due to wing stall during that transition, which would be at a critical phase of flight.
Got it.
So
you're basically able to hold the boundary layer close to the wing at all times as well with that, right?
Yeah, because the aircraft motion at that point in time is relatively low.
Right.
So chances are until you're in some level of hover or transition flight until you pick up enough lift to get the wing active. And then the other piece that we've matched up technology-wise with that is how else do we get the weight out of the aircraft, and how else do we minimize the mechanical complexity? So traditional aircraft use combinations of flaps and ailerons and rudders and tail sections. So we have done away with the tail because we are going to maintain directional stability using the dispersed electrical propulsion.
Right.
The other thing we've done is we've removed the ailerons and the other flight control surfaces and opted for a variable, thrust vectoring, but also the wings have a variable incidence. So we can independently change the incidence of the wing compared to its counterpart on the other side.
Yeah.
And that will allow us to minimize changes in motor speed for very slight variations in wing pitch on each wing, which will allow for control both in a hover and in forward flight. And because of the size of the wing too, those variations are going to have to be quite small, because you have a huge lifting area. So, half a degree may give you exactly the kind of control power you want in forward flight. So now that takes the mechanical complexity out of the wing, and we can put it in an area where we have maybe a little bit more real estate. I mean, it doesn't come without a trade-off. You have to figure out the incidence mechanism and how do I rotate the wing,
right?
Not only through the full range, but then also how do I do the minute control change ones, and what are the right rates for that? And,
that's a unique motor mechanism to do macro and the fine tune pitch encoding.
Yeah,
I would imagine that you have a much more complicated, though. There's a lot more that goes into finite element analysis of that wing load, because it's not a smooth laminar flow. There's the opportunity for more stress risers and whatnot at some of the sharper corners. Yeah,
there is, and we have spent a lot of time examining that. We had a CFD project with Autodesk using some of their high-end tools. We spent quite a bit of time developing the aircraft in their CAD software and going through that and doing the CFD, coming up with the loads on there, going through the FEA, looking at the wing, and we are now building a wing for bench testing.
Right.
So we've got a full-scale wing built, and we are looking at putting on a test stand, putting in a representative motor, and then doing a lot of the stress testing on the wing to make sure that it matches.
Yeah.
Making sure that it matches up with the analysis that we have, and then we're going to generate the lift out of it. And what kind of pitching moments are we going to get off the wing as the motor runs?
Right.
And then other things to take into concern are gyroscopic motion, because now we've got a spinning mass out there with a moment arm, and we're going to start rotating it. And what position are we rotating it around is probably not going to be the center of rotation of the disc.
You're dealing with precession issues that are different than what a 172 pilot would consider. Very different.
So complicated stuff.
Yep.
But that's what makes it fun. That's what makes it worth doing, right?
I can't think of a better person to do that than a helicopter test pilot. I'll be straight with you.
Well, thank you.
So let me ask you another question. How much of the development, the speed at which you can develop this vehicle is dictated by your own creativity and aerodynamics, and how much of it is lifted by just the current limitations in power storage density of today's batteries, supercapacitors, things of that sort? I have to admit, at some point, just how much power you can get in for a certain kilogram of weight of power storage becomes the global limitation of the design.
Yeah, I think so. In the practical method, engineering really comes to life when it comes off the academic page and goes out into the real world, right?
Yeah,
and that's what engineering is, right? Otherwise, it's academics and it's science. However, the great thing about the science piece of it is you're never going to rewrite the laws of physics, regardless of how much money you have, right? So get used to that. That is your ideal world.
Yeah.
But that's a good starting point. Going, okay, what do we think we could do? And is there anything in the assumptions from an engineering standpoint that have been previously overlooked? Right. So those are potential trade spaces. Your point is valid. The charge density, if we're going to keep this at the electric level and the pure electric level, which is batteries, and that is nothing more to a certain extent than offboarding the energy source to be generated somewhere else, right?
Yes.
I mean, whether it's hydroelectric power, whether it's other power station plants, whether it's nuclear, but you're going to be borrowing it from the grid somewhere. I don't think people are necessarily considering solar an option right now. That may just be a bridge too far for today,
right?
But definitely on the playing field. So that puts the pacing technology at battery charge density, to be frank, to get right down to brass tacks. And the smartphone, again, a huge driver in the improvement of batteries. Adding to that are electric cars. Further adding to that is the space program with power cells or hydrogen cells and using hydrazine. And there are some aircraft out there that are flying, at least at the experimental level.
Yeah, with hydrazine.
With a power cell on board.
That's obnoxious stuff to be dealing with, though.
Yeah. So, but so was gasoline when people weren't familiar with it, right?
Yeah.
And it,
agreed.
Very explosive, and all of these technologies do come with additional learning. And the nice thing about it is, and this is, I think, a fallacy that we often hear in society, is like, so-and-so's job is going to be replaced by technology. Yeah,
it will create
that may be true.
Yeah,
it will create 10 times more jobs on the backside
exactly
as that industry opens up. I mean, take a look at the day before cars and the day after cars.
Yep.
There weren't as many people in the car industry shoeing horses.
That's right.
Right.
That's
and
right.
so I got it. There's always
remember how much easier life was going to be because we had computers. I know my life is so much easier.
Yeah.
So let me ask you a WAG question on that, though. If today, I was reading, NASA's got this goal to reach a 4,000 watt hours per kilogram density for this type of market. What if tomorrow there were power storage devices that had 6,000 watt hour? That was just the next leap.
Yeah.
How would that accelerate going from a concept to part of our normal life, this vehicle that you're testing? If it existed today, would we be flying this within the next year or two, or what would be the next long pole in the tent?
Yeah, next long pole in the tent is get to the business side and the market space, right? So I've spent some time thinking about this, and I like to think of things in terms of three-legged stools. You have to balance the three legs of the stool. You can have any two legs, but the other one's going to cost you. So from that perspective, program managers think of cost, schedule, performance, right? In terms of the eVTOL, getting to a profitable vehicle today, if the technology piece was out of the way, is the business profitability piece, the public acceptance piece, and then the regulatory oversight.
Right.
So the governments are going to want vehicles that serve the public and fly through the air to be safe. The public is going to want to know that they're safe and accept them.
Yes.
In any major transition in a society, there were always holdouts. You have, your technology leaders, then you have, the majority, the leading majority, the lagging majority, and then you have the holdouts that were, no, I'm still sticking with the old stuff.
Right.
Yeah, exactly.
The early adopters.
Early adopters. Yeah. Crossing the chasm. So I'm speaking to all you folks out there still working with the typewriter. This is coming. But that has to be done, right? The public acceptance piece is no joke, because that's going to drive the business initiative.
Right.
That's going to have the business development parts of people's business looking to figuring out the technologies. That's also going to drive the government side when the mass of this and the momentum of this market takes off, that the government has no option, because from the government perspective, they'll see that, hey, this is potentially creating jobs, and that's one of the things that they want to do.
Right.
But so those things have to be kept in balance.
Yeah.
Right now, and this is challenging. Like, I think about this from other countries' perspective. So we have pride, obviously, here in the United States, and we want to be the first, and we have been the first in many other technological advances, going to the moon, supersonic flights, those kinds of things. But as our government becomes bigger and bigger, and maybe the regulatory burden and the bureaucracy is harder to get through, you see a lot of development happening in other countries, and now they're getting some first. So maybe not quite 2 years ago, the first certified electric aircraft in Australia.
Yep.
There were speed records set in Germany with electric aircraft. So we're not the only ones doing this, right?
No, without a doubt.
So, and you see in Dubai, I think EHang is another company out there that's got a octocopter-like design. And obviously, as a nation city, their regulatory framework may be easier and faster to navigate than ours. I think there are some aircraft flying out there on a limited commercial basis.
Is it
so
even
some people may already be doing it?
Is it well defined within the FAA ecosystem about what certification of this kind of a vehicle means? I know just trying to get UAVs to overflight the continental United States has cost years, just trying to define what is necessary to allow it to happen. Is your space well defined for certification?
So a little bit outside of my area of expertise on that. I know the FAA is very interested and very opening to adopting, and is very interested in working with industry across the spectrum of new aircraft.
Yeah.
the new approach is, before they used to have a very prescriptive approach going, an air vehicle needs to do this, this, or this. Now they're kind of getting towards what they call a means of compliance approach.
Right.
But they don't have the framework yet. Here's what I do know. I know the FAA is partnered with NASA, and they're also working with other industry leaders to best design a framework that they think that can meet the regulatory side for safety, as well as get to the corporate side of going, hey, how do we make this profitable and better for everybody involved, right? Because to a certain extent, we're starting with a little bit of a blank canvas, and we've got to integrate the current aviation that we have, the current aviation regulations that we have, and then figure out where are new areas to go, or what can we do slightly differently. Because at the practical side, when these aircraft get integrated, they're going to be connectors in their, at least as far forward as we can anticipate now in the future. They're not going to have very long ranges. People will make claims, but honestly, some of the early stage analysis that's been done is they will tend to be optimal between 10 and 25 miles, give or take. So which is great, because that's kind of where our cities are right now.
Absolutely.
You're not going to fly it one block down the street. You just walk.
Right.
You wouldn't even take your bike one block down the street, or maybe you would. I don't know. So how to, and then you can think about the large connecting hubs. So they're still going to be required to fly people in and out of airports, because that's where you're going to get to other areas of mass transit.
Right.
So maybe something like a subway system model in terms of deployment, where you'd have stops that are placed throughout a population center, as opposed to the Uber model, which will pick you up at your own address.
Yes.
And if you look at how Uber looks at this, they just look at it as another node in the transportation system. I get in my car, I drive it to the parking lot at the airport. The bus picks me up from the airport, takes me to the terminal. I get on the plane, I fly to my destination, and I do some sort of reverse through all the other nodes of transportation. There may be another node just inserted in there in that piece, as well as other types of transportation in and around city environments.
So with the Uber model, it occurs to me, let me check and see if I'm all wet on this with you or not. It seems like you're getting ahead of the state of another industry that is necessary to enable that. And that is wide area augmentation on steroids, right? If everyone has got a personal vehicle in their driveway, what does the government oversight look like to make sure that we're not colliding in the airspace and because there's no stoplight system in space. And it seems, tell me if I'm wrong, is the avionics infrastructure and industry and the innovation there keeping up so that when you have a vehicle that is ready to fly and to be monetized, that the appropriate infrastructure avionics wise, whether it be through AI or whatnot, is available to provide that oversight, regulation, and safety to those who fly these vehicles?
Wow, that's not a small question.
But it seems to be a big barrier to entry for the Uber site, right? There's another one like the Black Fly that they talk about, which is scary. The thought of, well, you can buy one and you can be certified as a sport aviator with as little as 20 hours. And you look in fixed wing with companies like Icon, that sounds attractive on the front end, and it almost bankrupts the company because sport aviators die because they don't have the experience.
So
one needs to think through these things.
Oh, absolutely. So I'll break down the problem a little by little.
Sure.
And I'm going to take the easy one first.
Okay.
Look, if nothing else, the airspace infrastructure already exists. Now, I don't think it would have sufficient capacity, and there would need to be significant modification, but we have rules of the road for the sky.
Sure.
Those exist, and people are well versed in them, because take a look at the millions of people that fly all of the time.
Sure.
Now, could they be scaled down to provide you the same rules of the road in a city environment? Because they're really set up for more long distance type of traveling. Again, we still have the educated workforce on all facets of that to at least tackle that problem. Not that it's an easy problem. I'm not saying it's an easy problem, but the people are there. And some version of that could be adapted and modified, I think, and is going to be adapted and modified to suit these vehicles. So yes. Now, then you get into a deployment question of, okay, I'm about to flood the sky with, 10x times the number of vehicles. How does the system respond then?
Right.
And that's definitely a challenge, and not one that I'm focusing too much effort on right now for me, because
no, absolutely. But one would assume the Garmins, the Honeywells, the Rockwells, that is a major focus.
I don't know if they follow these things or if they try and lead them, right? I mean, there's no money in it for them to lead it right now. They may just quickly try and follow whatever the FAA says is going to be the way. I mean, ultimately the FAA will be the decision authority.
Yes.
Not saying that they're doing that in a vacuum, but they will take that input, and ultimately they'll have to deploy some things, and it'll get massaged and adjust over time.
Yeah.
One would hope.
Right.
So I don't know, can they catch up with the avionics and the electronics really quickly? I believe so. I don't think that's terribly hard.
I think that's the question about running, and I like your approach, which is let's address how to crawl, which is it seems like the MVP application for you is exactly what you're saying, which is replacing the train, the subway, delivering people from Manhattan to JFK on a service kind of basis.
Yeah, I don't know if it would ever replace the train or the subway.
The internet was going to destroy malls, and there's still malls. They're dying slowly, but it's a process.
And bikes are still there as well, as is that typewriter, right? I mean, just the ratio of the technologies changes, and people still use the pen.
Yep.
And but getting to the harder problem in that question, the AI piece of it, and this is one that is not as clear. And I have my own personal thoughts on it, and I look forward to the spirited debate, particularly for folks that disagree with me, because I don't need people to agree with me. I need people to disagree with me, because there's something that I don't know in their perspective, because I trust that they've got their stuff wired up too. Taking the pilot out of the loop, and I often think of that military phrase, amateurs talk tactics, professionals talk logistics. So the amateurs in this case always look at going, oh, look, the computer flies the airplane. I was like, yes, but who's making all the decisions, right? The brain has just been offboarded from the aircraft and put somewhere else.
It's like the Air Force guys, it's not unmanned, it's remotely piloted.
Yeah, exactly.
Right.
Yeah. And but the challenge there is when you take a look at what a human operator does in the loop of an aircraft, not only do they do the day-to-day, flying of the aircraft, but they also monitor the systems, all things computers can do better than people.
Right.
Except for when there's no information, or for something goes wrong, or they got to make a decision, right? And now those decisions so how do you do that? Well, people make decisions based on a couple of things: their experience level, and then the set of circumstances they're presented with at the time. And they could make a range of decisions, and many of them would have very positive outcomes. And we are just better at doing that than computers are.
Yeah.
And then still communicating and thinking rapidly about what makes sense in the entire context of the situation when things change. So, and even today, aircraft are not, I guess even the piloted aircraft are still not fully pilot controlled, right? There's a controller on the ground guiding and providing some layer of automation to what the operator in the aircraft does.
Right.
So it's the team effort that still happens between, ground system integration, somebody looking at a much bigger picture versus somebody in an aircraft looking at the aircraft picture.
Right.
And, thinking that we're just going to take the pilot out and put the AI in, we can do the flying piece. That's not hard. We've been doing that for, 2+ decades.
Yeah.
And
UAV industry's proven that's ability.
Yeah. But it's okay, now what? Who's going to replace the Sully Sullenberger on the Hudson?
Yeah.
And or those kinds of situations.
No computer would have figured that one out. Probably.
Or even is it into Iowa several years ago, that one of the aircraft that crashed there?
And did the cartwheel and thrust vectoring on the way down. Yeah.
And in the thrust vectoring on the way down, and then the dozens of pilots that try to replicate it in the simulator afterwards, all of them crashed and died, and these guys managed to save it in the day, right? Still people perished in that, but it was far from the whole passenger load and the crew. So those are the areas that are going to be challenging. And then how do you prove that to people? Like, how do you So getting back to that three-legged stool concept, how do you get the public acceptance of that?
Right.
Right. Because that's going to be, hey, I'd like you to get in this aircraft. Well, who else is in there? Oh, it's just you.
Yeah, exactly. Yeah.
And then how do you get to the regulatory side of it? How do you get the FAA or EASA on board? And getting them on board is a significant feat in flight testing and kind of going through and showing that you've been compliant with all aspects of their airworthiness process, everything from design acceptance through production compliance, through continuing airworthiness instructions, as well as all of the training that goes in on the operator side. So there is this notion that somehow we won't have to do any operator training, and I'll tell you, the automobile is the most mature vehicle, and you still don't want to put your 16-year-old in it without at least some driving lessons classes, et cetera, and then send them out there in their version of a World War environment on an interstate.
Right.
And it only becomes more complicated when you add additional dimension and faster speeds and much higher consequences.
Right.
Much higher consequences to mistakes. Right. A car that runs out of gas just pulls over to the side of the road.
Yeah.
That doesn't happen with an aircraft.
Yeah.
Right.
So clearly the business model initially to create positive cash flow here is one that has a mission profile that has a professional pilot to begin with, it sounds like.
I think so. Others out there differ. We are building our aircraft with the hooks for autonomy,
right,
or limited amounts of autonomy, and that isn't even fully defined yet. What is an autonomous vehicle? But at the early stages, I don't see the operator coming out of the loop. Not if you want to integrate into national airspace, even at the peripheral levels, and even at the the lower density levels.
Yeah. So are you going to be the first one to fly this?
Absolutely. Yeah. Some people would say, brave or stupid, brave or stupid.
You only know after the flight's done.
That's part of the job. I mean, that's the test pilot thing, right?
Yeah.
We're going to deploy an aircraft for the masses. Somebody's got to be the first to fly it. And we like to get back to how we open this up with that disciplined approach. How do we look at this from the risk-based level? How do we drive that down? How do we know what we're doing? How do we build out and expand the envelope of operations of an aircraft? That happens with every aircraft that people have flown on today. Whether it's a 737, sometimes we wish it was done better, in light of the 737 MAX, but I mean, helicopters, military helicopters, those kinds.
So how does a company that is in the nascent stages, the startup stage, how do you duct tape and bubble gum that kind of I'm thinking before your flight, how do you build a simulation? I've been in a lot of Ironbirds, hardware in the loop type facilities. It's an extraordinary investment. You're taking a not as nearly as well understood aerodynamic vehicle. How do you build that simulation and whatnot while self-funding it or funding it at a level that is completely other than what a Boeing or a Bell helicopter would do?
Yeah, so that's a very interesting
business question.
It's a great one. You don't have to be perfect. You just have to be good enough, right? So there are some tools out there right now, physics-based models like X-Plane and stuff like that. If you can build your airframe in there, and now you can go through the simulation of it in flight and use that for control law development and all of those other things. And we've done that already. And we'll continue to work on maturing that, as well as using our subscale flying models, using a system ID approach to how does the vehicle react to flight control inputs, and then to understand that to mature the control laws. And you combine that with all of the other areas of flight tests that you have going on, and that's what you do to build a model. You start from, in flight tests, we start from a well-known benign position, and we just try and take incremental steps out and ask ourselves, did we get what we thought we would get? And then we review the information, and if we're satisfied that it's meeting the intent and the purpose, and then we roll that back in, and that now becomes the new kind of core flight envelope. And you just continue doing that till you get to a satisfactory level. And whether that's in flight control laws, in software regression testing, in performance of the vehicle, But ultimately, you got to go flying at some stage,
Yeah,
right? You
right,
do a whole bunch on the ground as well. So we will
right.
have a large portion of this will be ground test stuff, and then it'll move to the air. And I think we've been testing aircraft now for the better part of 100 years.
Mm-hmm.
So, not that people, as in humanity's always done it perfectly, but we're getting to a very, very good spot on how to do it, like from a principle perspective.
Right.
We know that well.
How much of this in the entrepreneurial side of designing new aircraft is informed by the mindset of people like a Burt Rutan, right? I mean, Burt Rutan really represents a forefather of how to make a significant contribution without a significant corporate engagement, right? Prior to him being bought by Northrop, right, with Scaled Composites. Do you find that is this a renaissance time for airframe development because the barrier to entry is lower because of innovation technology that's available today?
Yeah, I think there are a couple of things that are converging there. Yes, the barrier of entry is lower. I think the barrier for entry across all sorts of technology developments is lower.
Sure.
These days, right?
Sure.
I mean, you see things coming out of nowhere. The other things that matter there is the cost is lower as well. Thinking is a good use of time, and it's free, right? And getting to the right ideas and moving down there, and the fact that aviation is something that's always been done with scale in mind, right? You start small because you can go faster. So the startups have in their corner, as far as advantages go, is speed, the agility of thought. Even though the capital is small, they can deploy it how they want, when they want, without necessarily the bureaucracy, and then they can pivot more quickly.
Less overhead. Yeah.
Yeah. And then to quote Liddell Hart, who was a officer in World War I, the chief incalculable in warfare is will. Right. And I think you'll find that the will at the startup level is much, much higher, right? Because the people are there because of the passion and the personal investment in it, as opposed to, not to say that large companies don't do fantastic developments, they do, but how motivated is their workforce behind it? Yeah. To go without pay while still doing this, right?
Yeah, that doesn't happen. Isn't near as much. Yeah.
So those things, and then there are always people willing to help you. I mean, Autodesk helped us significantly, and just because we're working on cutting edge stuff that is good workforce development for their people too. It's not the kind of stuff at this stage that puts food on the table or brings in revenue at this early stage. But and I guess fundamental human curiosity still drives us forward as well.
Absolutely.
So those are some of the advantages. Yes, money is faster at the same time. I think if you don't have your idea suitcase, so the chasm piece, getting back to Jeffrey Moore there, if you don't cross that chasm with a little bit of bumps and scrapes and burns and hunger, then you're just going to waste it. Right? There's got to be a filtering process, and many startups fail and many succeed. And the nice thing about it is, you take a look at the Dow 30. There are probably very few companies on there that have been on there 30 years ago. I know
that's
Amazon
exactly
wasn't,
right?
And then there are some that have. 3M is on there and has been on there, for quite a long time, and a very innovative company. So there where there's a will, there's a way.
You look at they can exit or just as fast. I don't know, is GE still on there? If they're not, if they aren't, or they are, they're heading the wrong direction. So and then over time, the Facebooks and the Amazons of the world have turned into the Eastman Kodaks and the GEs of the world, and they will continue to do so, and somebody else will displace them. And that is the evolving nature of business. So let's talk about the future this is always the last question that I love to ask. But one of the great things about having the show is I get to meet fascinating people, and then I get to ask them this question, which is so that I get a chance to see them again. Let's say that you and I have the opportunity 3 years from now to sit down and have a beverage.
Should I pick you up in my aircraft?
I would love that. That's the question. What are we going to be talking about 3 years from now about HopFlyt, looking back and talking about, remember when we talked 3 years ago? What will have changed in the next 3 years? What do you imagine it to look like?
In the next 3 years, we will have our aircraft built,
Mm-hmm.
and I would be I'd be quite pleased if we are even a good way portion through our flight testing.
Mm-hmm.
Maybe just the hover testing, or maybe just even full power ground testing.
Mm-hmm.
But that's going to be where we're at, and how to get there.
Yes.
I mean, that's going to be the fun piece, right? It's never the destination; it's always the journey.
Yes. Yeah. And in that 3 years, what will this industry of eVTOL look like? There are some that are flying today in experimental
There are some that
phases.
are flying today, yeah.
So,
yeah.
How do you think that the industry will look? Will it have matured in some way? And if so, how do you expect that to look?
I sure hope so. It's interesting right now. I think the coronavirus pandemic is probably offering advantages to people like us, because I think on the large scale business size, the first thing they're doing is when they see the reduction in the bottom line profits, is they're looking at all of their kind of elective and discretionary monies, and that's getting constricted, right? That's what management from across a boundary that doesn't necessarily identify, or they've got to solve the short-term problem, as opposed to looking at the long-term payoff. They're pulling those funds back, so that's pausing those companies. We never had the money,
Yeah.
So it's
there's
business as usual for us.
Yeah,
there is a lot of freedom in that. And we're not tied to non-mission aligned constraints. So what does that mean? Like, everything we're spending our money on has got to do with our aircraft, as opposed to, well, all of the money that's coming in, well, it's got to go satisfy some other business constraints as well, which is, what do the shareholders think? What can we afford to do here? So that piece is good. I think you'll see there are some good companies out there that have aircraft flying, and some of them are big. I think Wisk is one of the ones now where Larry Page partnered up, or his company's partnered up with Boeing. So Cora partnered with Boeing to become Wisk, and that was, I struggle to track it all here from memory. Aero and Kitty Hawk, and those companies were all funded by Larry Page. Lilium out of Germany. 4 graduate students put together a very interesting aircraft design, and they had a couple of setbacks, but they've been flying on their prototype, and that's great. I wish them the best of luck. I tell you, I need competition, because that's going to drive me forward. And what I will tell you as well is, there's not going to be, just like there's not one maker of an automobile on the road, there's not going to be one maker of a solution here.
Of course not.
And then you'll see some of the other aircraft designs that are more helicopter-like. I think those ones will struggle. I don't think the future will look too differently. So you see Kitty Hawk is kind of going for the sport, kind of emotional entertainment vehicle. Hey, wasn't that a real thrill to ride concept? And you see some used for security services, whether these hover bikes tend to be adopted by police forces. I don't know if those will be suitable. What was that 2-wheel vehicle that was developed years ago and just recently stopped production? The one that the cops would ride on. Segway, exactly.
Segway, yes.
Yeah, right. That never quite hit the mark of momentum that it needed. So it's on. The great thing about it is Mother Nature and business are brutally honest, right? And if your dog don't hunt, you're going to know about it soon enough, because the customers won't accept it.
We have a saying here at Hiller. It's called "The truth succeeds on its own merit," which is we all have assumptions that at the end of the day, what's objectively true is going to win out. So,
I mean, if we got hit by something that we didn't anticipate, there are opportunities to pivot on this, right? We know that people want to put things flying through the air.
Absolutely.
And some of the more headline catching ones were, I know University of Maryland, through a collaborative program, recently flew an organ in downtown Baltimore, probably in the last year or so. And I've seen similar things with a remotely piloted vehicle, and they figured out the whole regulatory space with it as well. So they had to work with the FAA and all of that. But now you're talking about flying a UAV in a densely populated area, with somebody's life as the cargo. So those opportunities are out there. Vehicles of this nature that are electric are wanted at all scale sizes. So if So the opportunities to pivot are there. Let's say that for some reason we don't foresee us being successful in the passenger carrying space.
Yeah. Could be cargo of some sort.
Yeah, it could be, or it could be data and information. I mean, remember, when people move, they want to bring all of the stuff that keeps them connected with them.
Yeah.
So now, how do you create an agile information space? Wouldn't it be great if suddenly all of Verizon's or AT&T cell phone towers didn't have to be stuck to the ground, that they could move with
a heat map of data requirements. Yeah.
You know, I mean, that's an agile response to customer demand, and that's kind of self-regulating as well. Where the people go, the response goes, right? And then you see everything from, you know, temporary airborne networks and communication systems. Whether, hey, I've got a large sporting event, we're going to have, you know, Super Bowl in downtown Pax River next week, and let's get us a really high fidelity local area network set up. And by the way, we only need it for 72 hours.
Right.
So,
or emergency response, same kind of thing.
Haiti, you name it. You name it. Right. So those kinds of things are opportunities. You know, you have something, and if you have a technology that can rapidly deploy and suddenly change the infrastructure footprint and then disappear afterwards when it's no longer needed, that's beneficial as well. Right. So not always looking at the money side of things, but also looking at the time side of things.
Right.
You know,
Rory, we could go on and on about this, but you know, what I found doing this show is that our listeners like about 45 minutes, and I think we're there. So I'm going to bring this interview to an end, but I so look forward to continuing with HopFlyt's progress. I hope you don't mind as things provide. We would love to do an update, a sequel, a follow-on as HopFlyt continues to grow. And so I hope you don't mind if I pester you to do that here in the coming months.
I look forward to it.
We would love to tell the story. Yes.
I'll leave you with, you know, hop to the future.
I love it.
That's what we got to do.
I love it. I want the T-shirt. Yes, sir. Yeah. Thank you very much. Rory,
I've really enjoyed this.
And thank you for your service to our country.
Absolutely. And thank you to your listeners.
You bet. For next week, make sure you pay attention because we've got another great guest coming up. We're going to include Rory's URL. By the way, Rory did a fantastic TED Talk. We're going to include the link to that. You want to hear what he had to say from the TED stage. So make sure you stick by us, subscribe, hit the like, hit the bell, all that good YouTube stuff. And we'll see you next week right here on AE Squared. AE Squared is a Hiller Measurements Town Hall production. Copyright 2020. AE Squared is produced by Anthony Longoria. Production support by Christian Zamora. The email address, if you'd like to attend a future taping, is tickets@hillermej.com.